Hello. Apple, apple. Okay. So these are pivots, that is weights. These are springs. Okay. It is a spindle. Okay. Now these are magnets. This is a scale. Scale. Okay. This is called pointer. Okay, right. So see the concept here, we require three tasks in order to work. Listen, in order to work any instruments, we require three tasks. One is called deflecting torque, second one is called controlling torque, third one is called damping torque. Okay, so why we require these three? What is the importance of these three tasks? One is called deflecting torque. Deflecting torque means it is nothing but main torque. Main torque. Deflecting torque is nothing but main torque. Okay, main torque. Why? Because with respect to this deflecting torque only, with respect to deflecting torque only, this the measurement will take place. For example, see, whenever a current will flows through this wire, this coil, whenever a current of I is flowing through this coil, okay, so this coil, okay, here these are the magnets. So this coil is a current of I is flowing. What happens? Magnets, for example, magnet is there, one iron piece there. What happens actually? It is a magnet, iron piece is there. What happens actually? This iron piece try to attach here. Yes? Right. If two magnets are there, north pole and south pole, what happens? They will repel each other. If north pole is there, north pole is there. No, they will attract. If north pole is there, north pole is there, they will repel. If north pole, south pole is there, they will attract. Okay, at the same way, whenever a current of I is flowing through this coil, okay, so in this coil here the current is I, upward direction. In this coil the current is downward direction. Okay, so this coil now turns to move like this. This coil is turns to move like this. So this spindle will move like this now. Where is the previous? Here. It is moving now. It is moving like this. Spindle is moving up to not rotation, not 360 degrees, up to maximum. Up to maximum. So here is the final position. If you want to measure the total 10 amps, final position. Okay, now I am removing the terminal. I am removing the terminal. Where is the point? Where is the point? It is at that point, that place only. If I remove, okay, listen. If I apply the current, because of the current flowing through the coil, it will deflect. It will deflect. This one right side, this one right. So like this it will deflect. So the spindle move like this. So okay, whenever move, okay, so this deflecting, moving is nothing but deflecting torque. Deflecting, this is moving like this. Pointer is moving. Pointer is moving from zero position to like this. So this is nothing but we require torque. That torque is called deflecting torque. That is called main torque. Now I remove the terminal. Current is zero. what happens? It has to move to the 0 position like a rubber band. Stretching. Now it is here. It has to be 0 position. How? It cannot go. It cannot go. What you have to do? So see, here we are having springs. Here we are having springs. So whenever it is moving like this, these springs get tight. Okay, whenever it is displaying, these springs get tight. Whenever I am removing the terminals, current is 0. This, okay, there is no power, there is no deflecting torque. It retains its first position. Immediately it is, okay, it is moving, the springs get tight. Whenever there is no current, it will go to the previous position. First position, this is the first position, initial position. So one is deflecting torque, second one is controlling torque. Controlling here, who is controlling here in the above diagram? Springs are controlling. Springs are controlling. So controlling torque is obtained by the springs. Why we require controlling? If there is no springs here, it is its position only. It will not move to the 0 position. It will not move to the 0 position. Okay, right. So I think all of you riding the bike. Okay, accelerator is there, na? You are giving acceleration. What happens? And gear. What happens? Bike start moving. If you remove hand, what happens? It retains first position or it is at a high position? Acceleration. If you remove hand, what happens? It goes to the first position. Yes, do you understand? Acceleration. Okay. Increasing and maximum. You remove hand, what happens? It is at that position only. Maximum position. Or it goes to the first position. Yes, at the same concept, whenever there is no current because of these springs, okay, it retains its first position whenever there is no current. Okay, right. So that is called controlling torque. So controlling torque is obtained by here springs. Spring. So deflecting torque can be obtained by the spring control. One of the type is spring control. Controlling torque is obtained by the spring control. Deflecting torque is nothing but main torque. Right. Third one is damping torque. Damping. What is the meaning of damping torque? Damping. What is the meaning of damping? Damping. What is the meaning of damping? Dancing, huh? Damping. What is the meaning of damping? Damping. So damping is nothing but, okay, for example, so here see, it is moving, actually it is measuring. For example, 30 volts is there, pointer is at this place. Okay, after applying the circuit, after connecting the circuit in this meter in the circuit, okay, this pointer initially it is at a 0 position. Now it is moving at 30. So 30 is the voltage, for example, let us say. So at this position, it is not maintaining its constant. It will move like this. Dampier. Okay, like this. It will move. Damping. Damping is nothing but like this. You understand now? Damping is nothing but see. It is not at a 30 position. It may be 29.5 or it may be 30.5. Yes, moving from 29.5 to 30.5. That is called damping. It is not measuring 30 now, like this. This is called damping. Okay. Small disturbances of the pointer is known as damping. That is called damping torque. యా సార్ ఏమన్నారు? సారు మరి ఏమన్నా ఇప్పుడు టైం ఎంత అయింది? 4 అయిందా? 4:30 వరకు చెప్దాం.
4:30 వరకు చెప్పు నాకు. అంటే తర్వాత వీళ్ళు ఏమనుకున్నారంటే 4 to 5 ఏమైనా టెస్ట్ పెట్టుకుందామా ఈరోజు చెప్పిందని అన్నారు.
4:30 మేడం అడగండి. 4:30 వరకు చెప్తాను. 30 ½ అవర్ ఏమైనా పెట్టుకో మేడం. I will continue up to 4:30. I will continue up to 4:30. Hello. Listen. So dampness means it is moving a small displacement. That means, or you can say shivering. I think you know shivering. Like this you will say. Antam kada shivering వచ్చిందని అంటాం కదా, అది that is nothing but damping. So whenever the pointer moves from 0 position to 30 position, this is called deflecting torque. The torque required to move any pointer from one place to other place is nothing but, that torque is nothing but deflecting torque. Controlling torque means whenever there is no current, whenever there is no supply, the pointer has to retain its first position. The torque required to retain the first position is nothing but controlling torque. Third one is, in order to avoid the damping of the pointer at one place, we require damping torque. We have to avoid the torque. Okay, we will not generate damping. We are avoiding the torque. That is damping torque. Damping is nothing but small displacement, or you can say shivering. Okay, like this. Okay, it is not at one place, it is like shivers. Okay, right. Now so this is PMMC instrument. This is PMMC instrument, permanent magnet. 2 magnets are available, permanent magnets. Moving coil is moving. This is a coil is moving. So permanent magnet, moving coil instrument construction. Okay, so deflecting torque obtained by the, how can we obtain deflecting torque? Deflecting torque obtained by the coil. Controlling torque is obtained by the springs. Damping torque obtained by the pivots, weights. Okay, weights. Okay, so here depending upon the type of usage, okay, deflecting torque is nothing but main torque. Deflecting torque is nothing but main torque. Controlling torques are 2 types. Deflecting torque is nothing but main torque. There is no different, there is no classification. These 2 are required. These are the 2 additional torque required to maintain a constant value. It has to measure 30 volts means it has to measure 30 volts. 1 amp means it has to measure 1 amp, not 0.75, not 1.15. It has to measure constant value. Okay. So here this controlling of torque, that is deflecting torque, can be obtained by using these two. One is spring control. Spring control. Second one is gravity control. Just now I have drawn that one. That is permanent magnet moving coil. There we are using controlling torque is obtained by the using springs. So another one is gravity control. I will show that diagram also. Gravity control. So controlling torques can be obtained by using springs, by using weights, that is gravity, weights. Third one is damping torque. So damping torques can be obtained by three ways. One is called air friction damping, fluid friction damping, and third one is eddy current damping. Okay, so these are the three required for the controlling of, in order to dampness. We have to remove this one. We have to remove the damping. So we require special arrangement. So there are three arrangements are called. One is air friction damping, fluid friction damping, eddy current damping. Okay, right. So listen, I will explain this one in the next class. Before that, we will complete this one. We will complete and we will stop. Okay, right. So with respect to cell bus is concerned, with respect to cell bus is concerned, PMMC instrument is there. Just you have completed, and I will explain remaining three talks, remaining damping talks in the next class, and moving iron also in the next class. Okay, we will complete this one now. V-stone bridge. V-stone bridge. This is the topic in the second unit, last. V-stone bridge. Do you seen this V-stone bridge in the lab, in physics, in inter? V-stone bridge. What is the use of this bridge? Huh? What is the use of this V-stone bridge? What is the use of V-stone bridge? You don't know? I myself also don't know. Okay, right. So V-stone bridge, it is also, we are measuring one of the quantity. We are measuring one of the quantity. What quantity? Any quantity. So generally we are measuring. Okay. So V-stone bridge consisting of four arms. Right side 2 arms, left side 2 arms. In between these 2 arms, middle galvanometer is available. Galvanometer. Do you know about galvanometer? Right. So here this V-stone bridge is used to measure the unknown resistance. V-stone bridge is used to measure 430. 430. So here అయిపోయింది కదండి, అది కూడా టైము 4:12 అవుతుంది, ఇంకా 20 minutes అంతే. ఓకే, సో V-stone bridge is used to measure unknown resistance. Okay, unknown resistance. If the resistor is there here, what is the value? You don't know, which can be obtained by calculating. You will get the value now. Okay, unknown resistance you will get. How can you calculate this value? Let us see. Okay. So this is called Wheatstone bridge. Here we are measuring one of the unknown parameter. What are the parameters? Resistance, any parameter. P is the resistance value, R is the resistance value, Q is the resistance value, S is the resistance value. Okay, here your aim is to measure any one of the parameter among the P, Q, R, S. You know the value of P, you know the value of Q, you know the value of R, but you don't know the value of S. How many parameters are there? 4. Among the 4, you know only 3. Remaining you can be obtained. It can be obtained by using the formula. What is the formula for Wheatstone bridge? P by Q is equal to R by S. Do you know the derivation? Do you know the derivation? Which derivation you are using? Physics derivation? No. So here, see, apply voltage to the Wheatstone bridge. Apply voltage to the Wheatstone bridge. How much current is flowing? I current is flowing. So this current is dividing as I1, I2, I3, I4. Okay, so here how many currents are there? I is dividing as I1, I2, I3, I4. Okay, current is leaving from A. It is a leaving from A. Write down KCL at B. At B, write down KCL. So the current through the galvanometer is Ig. This is a galvanometer. Current through the galvanometer is Ig. Apply KCL at B. KCL at a node. Algebraic sum of the currents entering towards the node is equal to algebraic sum of the currents leaving from the node. What are the currents are leaving here? What are the currents are leaving? Ig is leaving, I3 is leaving, is equal to I1. That is I1 is equal to minus Ig minus I3. Name it as minus is equal to 0. Name it as equation 1. Second one at D. At D. Apply KCL. At D, apply KCL. At D, apply KCL. Here I2 is entering, Ig is entering, I4 is leaving. So here at D, entering are I2, Ig also entering, leaving I4 is equal to 0. Second equation. This is the current equation, first current equation at B and second current equation at D. So these are the two equations. Now write down KVL. How many loops are there? This is the first loop, this is the second loop. Okay, write down KVL at this node. Okay, right. So here what we'll see? Current through galvanometer must be 0. Current through galvanometer must be 0. Okay, so if we apply current Ig is equal to 0, this first equation will become as equation 1. So I1 is equal to I3. Second equation I2 is equal to I4. Okay, name it as equation 3, equation 4. Okay, and now apply KVL first loop. Apply KVL for loop, first loop. P is the resistance, P into I1 plus or minus minus. So R, this is plus only, plus R into I2 plus Ig into its resistance in nothing but G is equal to 0. Okay. KVL for this loop. Okay. Applying KVL for first loop, which is becoming now I1 P plus IgG minus I2R. KVL. Second loop, this one. So here in this second equation, this equation KVL first equation, KVL second equation, here Ig is 0, Ig is 0, Ig is 0. Now I1P is equal to I2R, I3Q is equal to I4S. Now divide equation 3 P is equal to I2R. Then I3Q is equal to I4S. What happens? Here I1 is, what is the value of I1? I1 is equal to I3. So I1, I3 will get cancelled. I2 is equal to I4. So I2, I4 will get cancelled. So here we got the equation as P by Q is equal to R by S. If you know any one of the, if you know any three of the parameters, you are able to find out remaining one parameter. So this is about Wheatstone bridge. You will get this derivation in the exam. Okay. Okay, we'll complete this here. We'll stop here. In next class, we'll discuss remaining topics as well as third unit also. Okay? No, you don't go. Can I ask questions? No? Why? One more question, two more question I will ask. What is the no, you can write down, very, very important. What is the function of brush in the DC generator? What is the function of brush in the DC generator? It will clean the teeth of the human being. Antena? Function of the brush in the DC generator. It will collect the current from the commutator. It will collect the current from the commutator. Next one. What is the function of commutator in the DC generator? What is the function of commutator in the DC generator? So commutator is a device which will convert AC to DC. Okay? Right. What is the function of pole shoe? What is the function of pole shoe? What is the use? it will displace the flux equally to the rotor conductors. 1 mark means a single line answer only. 1 mark means single line answer only. Okay? Right. What is the EMF equation of the generator? EMF equation of the generator. Pi ZNP by 60A. What is mean by P in above equation? What pole? Number of poles. Okay. What is A? What is A? First letter of alphabets. Write down that answer, you will get 1 mark. A is equal to number of parallel paths available in the DC generator. What is N in above equation? Speed of the DC generator, or number of revolutions per second. Okay? ఇవన్నీ మీకు 1 మార్క్ 2 మార్క్ రావాలి, రాకుంటే కష్టం. ఓకే, ఫ్రమ్ హియర్ ఆన్వర్డ్స్ మేడం విల్ టేక్ కేర్. ఓకే, రైట్, థ్యాంక్ యూ. ఓకే, ఇఫ్ టైమ్ పర్మిట్స్ ఐ విల్ కమ్ నెక్స్ట్ వీక్, అదర్వైజ్ థర్డ్ వీక్. థ్యాంక్ యూ.